I would like to welcome Naila very much to Google. Naila is going to be talking about activity stage framework, and I hope that the sort of the subtext of everything that she will tell us about. She has been doing some wonderful adventures in trying to combine machine learning with activity theory with conversation analysis. So that is just mind-boggling interesting. So please go ahead and give us details.
All right. Okay. So good morning, everyone, and thanks for being here. So just call me Naila. And currently, I'm a postdoctoral researcher at the Honiden Laboratory, National Institute of Informatics in Tokyo, Japan. So this morning, I'm actually going to present my PhD dissertation since 2 years ago on activity states framework, which is a theoretical framework for the analysis of actual human collaboration on the web. So this is the outline of my talk for this morning. First of all, I'm going to try and get all of you into the overall story of how the framework came about and what it was for in the very beginning by sharing you a little bit about the background, history, and the goals. And then I will proceed to introduce the framework, and then I'm going to show a sample of how it's being done. And finally, I will move on to the discussion. What are the shortcomings? What can we learn from this framework? And then evidently asking ourselves, like, where do we go next? So the framework has history actually in two domain, which is on agent, technology, and work practice. While I was a PhD student at LIRM CNRS, my PhD supervisor had this idea to conceive a learning agent that can induce communication protocols of another agent on a grid infrastructure. So what we mean by communication protocol is the ability for the agent to infer a new context of communication and to knowing what to communicate with whom, and with when. So similarly, in 2004, I met Bill Clancy, who's the chief scientist at the Human-Centered Computing at NASA Ames. And he read my paper, a workshop paper on the agent and communication protocols. And then he came back with a handful of comments in future direction. So he started to narrate the challenges that they were facing during the NASA Houghton Mars project, for short form NASA HMP. And what this NASA HMP project is about is actually it's an exploration project which is aimed at developing new technologies on agents and tools to support people collaborating in cross-domain collaboration. And one of the aim is to design these tools so that you can support robots and humans to explore Mars and other planets in the future. And so the main challenge was simply this: how do you understand the communication, how do people induce communication protocols in cross-domain collaboration for Clancy during the NASA HMP? And I'm going to explain the two contexts where it's concerning understanding communication protocols in cross-domain collaboration. So the first challenge is, how do you enable robots to communicate with astronauts on Mars? So one of the difficulty that they had was to develop the robot. The robot did not know when a communication with an astronaut, for example, has come to an end, or whether the communication is still in a pause mode. My work activity with you hasn't ended yet. And it makes it even more complicated when the robot, for example, has to communicate with a geologist or a computer scientist, because all these experts has a different way of carrying out their work practice. So then the question goes back, like, how do you enable agents able to induce communication protocols? Now, the second challenge is about NASA HMP members collaborating with outside organizations through email. So Clancy had like a short experiment in 1999, and two events took place, actual events, which the first caused problem to the team members. So what happened was, one of the NASA members was allowed to have private email with outside organization, and the context that they were discussing was about the safety issues at the habitat. So that's a habitat. So where they go and simulate their work practice. And it actually affected the group decision problem by allowing this direct communication with the outside experts. But on the other hand, during another event where the NASA members were communicating with outside experts on weather forecasting, there wasn't any problems at all. So it actually, in fact, the group were in a mutual collaboration process, learning collaboration process. So then again, how do you know when to allow the members, the NASA members, to use email to collaborate with outside organization on, for example, explaining about safety issues procedure or on weather forecasting? So then it goes a bit again to how do people induce communication protocols in different contexts of communication. So
You
sorry.
said that it caused a problem?
Yeah, it caused a problem.
And so the problem was what? What was the nature of the problem?
Okay, so what happened was he, after directly communicating with the outside expert, he had his own interpretation of how the safety issues, the procedures should be carried out during the simulation at the habitat. And as you know, that the NASA members there are in a hierarchy, in a power order. So you have the mission support, the commander, and the crew members. So the member who communicated was the crew member, and the commander is supposed to control the communication on a need-to-know basis, so that all decision is being made by the commander, and the crew member is supposed to follow the decision. So because of this direct communication with the outside expert, this crew member did not agree with the commander's way of handling the safety issue. Instead, he said, you know, I've had this direct communication, but I don't think we should be following this way. I think from my own interpretation, we should carry out the safety issue in this manner. So that was the...
Okay. So one important point is that when you said communication protocol, I imagine one thing about, you know, sending pieces of information back and forth. And this is a failure of the sort of power or hierarchy protocol, not necessarily the communication protocol. I know those get entangled, but they're two separable ideas, I think.
So, okay, so when I say the communication protocol here is, again, I say that how do you infer the different contexts so that you can know when and what and how to communicate with in that situation. So in this context of problem, in fact, what happened was both of them they were in a breakdown situation, because for the team leader, there's a discrepancy between what he knows how to normally communicate through the protocols and what actually happened as the effect of the event.
Right. No,
so,
I understand.
Yeah.
It's just that you're using the term protocol in many senses here.
Ah, okay.
You're using it in a sense of social protocol, in a sense of power protocol, and in a sense of communication protocol, which I take to be sort of messages going back and forth. And when you talk about inducing the end of a communication, I think about that in sort of lower level than I think you're meaning it. Right? Is it when did you hit the end of your paragraph? Right.
Yeah,
versus I don't believe what you're saying because you spoke out of turn with an external expert. So it's different levels of abstraction.
All right, okay. So, and then so I set the long term to find, to understand how people induce communication protocols in cross-domain collaboration. So why would such findings be important for NASA HMP is that to allow some sort of prediction of communicative behaviors. So because with the prediction, you can know the implications of actions. So if there is a discrepancy between the robot-human communication, how would you allow the robot to handle that discrepancy, or what sort of tools can you build to incorporate that discrepancy? And then if you allow them to collaborate on internet, for example, what if GTalk is allowed as a communication tool with outside experts? What are the consequences of that? And this is when I did a little bit of virtual ethnography. So I had to find a similar context of study. And I used the European Learning Grid Infrastructure project to carry out my observation. So the ELIGI project was a European Union-funded project in 2004. And they had this goal to re-engineer present tools, buddy space instant messaging and flash meeting, which was developed by Knowledge Media Institute at Open University, and also to build new ones to support a group of chemists collaborating in Europe. And one of the future goals is how do you use agents that can communicate with people to carry some of their tasks for them. And what was interesting was during this collaboration, there are many different experts. There were cognitive psychologists, computer scientists, IT people who whose communication were mediated by all these tools. So I focused on one subject, which is the project executive of the project, of the Elijai project, and I tried to keep track of his communication with other group members during the collaboration. So I got permission to get real chat logs and video meetings, and for the chat logs, I had the project executive 6 months history chat logs with another project manager, and for the meeting, there were about like 5 or 6 people having regular meeting like once in 2 weeks. So I had about 4 meetings to analyze. So that's the Buddy Space user interface and the Flash meeting replay. So, so when I had these chat logs, then I had a lot of problem analyzing them because, so first of all, I'm going to show an excerpt of the chat logs, and then I'm going to explain why it's very problematic to analyze it. So I highlighted in different colors to show the sort of different activities that people are engaged in on the chat logs. So if you look at the threads in blue color, they're in the activity of, they were using map, one of the features of the Buddy Space instant messaging, and how to personalize the features. And then the pink one, suddenly the collaborator M is talking about he needs to log on and off for testing. So actually, in the previous history of the chat log, they had presence problem on the instant messaging. So, you know, suddenly he goes back and say, I have to get back to my previous activity. And if you look at the brown, the brown one, now what happens is that the other collaborator is asking, you know, could you ask me how to add a new user to the Buddy Space, but not yet in Elijai. So the problem is, why is it ambiguous? It's only because at first you don't know who is replying to what in that context because of the multitasking, inherently the multitasking nature of people. So the beginning of a new subject when they're discussing doesn't end in a sequential order. So you actually have to go line by line to actually find what were the contexts, what were the events that emerged. So again, because I wanted to understand how people induce protocols in different contexts of communication. And then going further back, at an abstract level, it's really hard for me to find patterns that can explain to me how people induce communication protocol. And so I had to find a way to capture this semantics of the activity of people and make it explicit. So later on in the future, we can have sort of like a machine learning algorithm that can learn those induction of patterns. So I reestablished my goal that instead, for now, to make an analysis that simply can help me make sense of the very ambiguous chat logs. So if you look over here, that's the raw chat log. So what I mean by to make sense, from here, you have an analysis that tells you, okay, from time 11:06 on this date till time 1:30 on this date, user M was in the activity of giving tutorial how to use instant messaging. And then from this time, where's my cursor? Sorry. So from this time, 15:23 on this date till 14:50, user M was in the activity of organizing a trip to Montpellier. So from making sense of the activities, we can go further to recognize events that emerge during the collaboration. So the event is like saying the sort of activities that took place in order to, how to say, for example, okay, if you have the event of coordinating meeting in Montpellier, so the first activity they do is first they start chat, and then they pause, they use the email, and then they go to check their calendar, and at the end they go to the activity of group chat or video meeting. So you have sort of like a beginning and opening of events, and you can sort of like understand what they do in between all those events. And it was from here that my goal was to make the analysis that to make sense in the first place was how activity states was conceived. And the analysis was first and foremost to sort of like reorganize the chat logs. And it was aimed at making sense of the communication activities, and it was based on cognition theory. So I used cognition theory to help me organize the ambiguous data, first of all, like what to look for and what do I do next. And again, once we have that, how do I capture the semantics of activity and make it a bit explicit? And so sort of like now you have the observations of the raw data, and you need sort of like a guideline. How do you bring the observation that your eyes can see? And this is how FIPA ACL came into the picture. So FIPA ACL is the Foundation for Intelligent Physical Agents, and it's a Swiss nonprofit organization established in Europe in 1996. So the FIPA ACL organization aim is to define the full standards of agent communication, their ontology, their protocol. And what it was nice that I used the FIPA ACL communicative acts because they have defined the semantics for speech acts, like say inform ref, request whatever, query if. So I used this as a springboard using similar idea. So to capture the semantic of utterances using speech acts, they use belief, desires, and uncertainty. So it's like you have this guideline and you have the observation. How do you map them back? And the FIPA ACL, they have, so as I say, they have a guideline on how to specify the agent messages. So this is how I use the format to sort of like, I use the format to output my analyzed data. And the format is in like, you see there's speech X and who is the sender and who is the listener, and there is a content level A. So at the content level A, it is sort of like they give you the freedom to specify the kind of structure you want for the content level. And for me, I use the predicate level because I wanted to enable protocol analysis later on. So for example, you have a car, which is an object, and then M, which is whose car it is, and nice, which is to describe, your car is nice. So overall, you have the raw chat logs, and the activity states sits in between the chat logs and uses the FIPA ACL to output it as agent messages. So the activity states is like what to look for, where to go next. And then you have a string, you have the output of the raw chat logs sort of like in a protocol. And so before I introduce the framework, because during the framework, I'm going to repeatedly sort of like use these basic ideas. And since I mentioned that the first idea is to use cognition theories, right? And how do I use it is that I look into cognition processes as functions for organizing the data. So you see here, I put the function in 3 levels to show how from an idea, a general abstract idea, to a more detailed level. And at each of this cognitive process, it's like you're evaluating and what is the value that you return at different levels. So when I speak about the value, I'm not speaking value of like numbers per se, but rather, for example, if you ask conceptualization, what is he doing? So you return, oh, he's coordinating the data. And then you go deeper and you want to get more information, which is calling contextualization. So what is the activity in the coordinating meeting? So it returns scheduling meeting date. And it goes further down to get more information about that activity of scheduling meeting date. So then there's a function reflect. And here I use activity theory from Leontief on object and subject. So it asks you to pose us a question. What is the object and subject of his activity? So object is like what is the focus at the moment while he's in this activity, and what is the referential process while he's conceiving his his motivation at this time. So then it returns a value to get the confirmed date by today. And secondly, now that you have the observation, where do you go and what to look next is secondly to capture the semantics of the states of activities with speech act. So here, I mentioned that the object subject is used in the function reflect. So again, the object is the focus at the moment. The subject is the referential process of the object there. So secondly, I use the idea of fluctuation of activity states. And this is actually my observation, how they were doing their activities while they're collaborating. So I use this fluctuation to resemble the open and the pause and the end of activity towards reaching a goal. And I identify 3 states passive, which is they're just starting in the activity of coordinating a meeting. Semi-active, they're in between of just starting and towards reaching the goal of the activity. And the active is the near ending state. So I use belief, desires, and uncertainty to capture this. Now, why did I do that? This is just to show you how it is. And passive, in other words, is just to show the local minimum, and active is the local maximum of the activity. So the reason why I try to capture the semantics in this way is because the activities can overlap. So let's say you're just in the activity of coordinating a meeting, and your goal is at the end of the day to get all the particulars about the meeting. But while you're in this activity, it can overlap with another activity, which is debugging an instant messaging. So you're sort of like in a suspension mode to completion of the activity. So the passive and the semi-active and the active states helps me to segment, like trying at a fine-grained detail the moment that the intention changes in respect to the intervention of another activity. And the second reason was because, remember I mentioned that FIPA-ACL has already a set of all the semantics of the speech acts, but it was a little bit difficult because it's very close, like request whenever it's, the semantics is a little bit close. So by using these different states, sort of like I'm trying to cluster similar representation of speech acts so I can easily map them back to the defined FIPA-ACL, the speech acts defined. And,
question.
oh, sorry.
I think I missed a little bit about
Yes.
that. What is the passive, semi-active, and active? I think
Oh, sorry. So it's like, so the passive is just to denote an idea that the person has just started that activity. And the semi-active is just to show that, like saying, oh, can you please send me that file now? So it's like people are already in the action of executing a task. And the active is saying like, you have, okay, I already got that. It's wonderful. It's perfect. Great. It's just to show that, okay, the activity of coordinating meeting has been completed.
Okay, so you're mapping based on the speech acts that that are basically from the law, the transcript. And you're basically mapping them to the passive to active.
Yes, yes.
So is this a continuous dimension?
Oh, so actually I just showed this line is to show the degree of the different attention mode that people can be on.
So the red,
the red line, yeah,
is the intention, or
is the cognitive state of person, the activity. It's like
I'm missing it.
Okay, sorry.
I'm missing what are the units that's measured in?
To whether it's passive or semi-active.
When you draw a curve like this, I assume there's some kind of dimensional measure here, right? And then you've got it looks like you've got it broken up into categories, like this region measures is passive, you've labeled passive. And so on, right?
Yeah.
So I don't get what the y-axis is. Why is that a continuous curve?
Oh, so the reason, okay, why it is a continuous curve is it's sort of like to show it's not to show actually, but it's actually to capture the flow of people when they're collaborating in different sort of activities that may overlap. So the continuous curve is saying like, okay, you're in this cluster of activity in coordinating meeting. So you're just starting, okay, you're reaching the maximum now, you're both executing, and you descend by that, okay, it's already done, we're finished with coordinating a meeting. But even before you are just about to finish, a new activity 2 comes in, which is just starting, and you're just now starting to
right, so that's handled by time.
Yeah, it's like a time. Yeah.
But the confirm. Sorry, I'm still lost on that one. So the confirmed date is really a part of activity 1.
Yes. So they reappear again
What
in
does
activity
the
2.
dotted square mean?
So it's just to show that there are different activities.
So is the y-axis basically attention and activity?
Yes.
And so the x-axis is over time.
Yes,
and
the time.
And the line represents
for an individual or
Yes.
group, the stream of activity?
Yes. Okay. For one collaborator. So it's just trying to capture like the different shift of attention in a continuous flow. So
They're overlapping conversations and activities
Yeah.
over time, and the amount of activity.
Can you
that
actually
occurs.
measure?
So, yeah, that's a little bit hard to answer how to exactly measure that. So the way that I measure that I use the FIPA ACL, so they already have the standards like belief, desire, and uncertainty. So at every different changes, let's say the second iteration, he says, "Oh, I've got that. Can you please send me again?" So I sort of like increase. Oh, he believe. So you go into the definition that you increase the belief now that it's much stronger than the previous belief, but now the uncertainty level that the person doesn't know about this subject has decreased, and then the desire to get this activity completed is increased more. So it's actually playing with the belief, uncertainty, and desire. So this is one of the shortcomings that I have to discuss later on, is how do you actually evaluate that.
So the y-axis is basically the translation estimate of your understanding of the cognition of different things over time.
Yeah, over time, of one collaborator communicating with another one. Yeah.
So you have different colors for the dots?
Oh, yeah.
So they mean different activities?
They're different focus, different subject. Like in the coordinating meeting, you can talk about scheduling, you can talk about flight, when do you want to come to Montpellier, and then you can be engaged in what sort of equipment should I bring when I go to the meeting. So the dot is to show, so you have this like on a surface, you have this activity coordinating meeting, but there are many sort of like focus or objective in the meeting, to get dates, to get confirmation. So that dot, that little circle, is to show like the different type of focus that appears during this activity.
What about the overlap between activity 1 and activity 2?
Again,
are
like,
they separate activities, or are you suggesting that some events are part of 2 different activities?
Yes, it could be. Because what I noticed is, for example, it happened quite a lot that by accident, by chance. So for example, they're in the activity of giving a tutorial. So the activity 2 is saying that it overlaps, that it can also, it can emerge as a new activity from the tutorial. So what happened was they were giving tutorial, and one of the guy noticed that he noticed that the color of the presence was different from while listening to the tutorial. And from this activity, suddenly it went to a new activity, which is debugging the tool. So actually there was a problem with the presence. So it's actually time to keep track of the possibility that if you're in this activity, what are the possibility that, a new activity will emerge.
Okay.
Yeah.
Excuse me, I have to transition to activity 2.
But I will see you later.
Okay, all right.
So you have 3 activities here. So they are sequential.
Oh, this is like in sequential order, yeah.
So activity states here is for single activity, right?
Mm-hmm.
Passive, semi-active. But they share the same curve here, right? So so I'm trying to figure out the states here. They're for one activity, or it's for the performance of multiple activities.
The performance at each moment during the activity. I know that's really, I know a lot of people like, yeah.
One more question. You brought up the belief,
Desire
desire,
and uncertainty.
And you suggested that you use those to code their statements and therefore determine their state, active,
Exactly.
semi-active, and passive.
Yeah.
Are you going to talk about the mapping from those 3 states to these active versus passive states?
Oh, so in this talk, I'm not going to talk about the mapping because it's, but I can go that further on later. Yeah. Because actually that's the biggest challenge. How do you map? So now that you have the observation and you cluster, sort of like you're categorizing from your own observation, and then you have what is defined in the FIPA guideline. So now you have to sort of like merge them, you know? How do you know how to map from your observation to the FIPA guideline, and in which categories does this semantics definition fall into? So it's sort of like trying to minimize the search space for speech acts. So that was my idea, because I was having problems, you know, there's so many. How do I know which speech act to choose? Because they're a little bit the same, the semantics sometimes. So yeah, sorry. So the workflow, I hope you guys can see, because it's a little bit small here. I tried to fit into the screen, sorry. So, so this workflow is really at the coarse grain level, and
Whose workflow is it? Just help me.
So it's like the framework, the analysis. So
if I use your framework,
as an analysis, yeah. So throughout the workflow, I'm going to mention traits a lot. So trait is just I'm going to say a lot about present trait and previous trait. So what I mean by present trait is this one, and this is previous trait. So let's say we have a set of chat logs. So the first function is conceptualize. So what it does is you're trying to compare the activity of the present trait and the previous trait. So then you make a decision, is it the same activity? So if you look in this example, it's not the same activity. One guy is talking about sorry disconnection, and another one is talking about which time it's more convenient for you. So if it's not the same activity, if it's a same activity, but on the other hand, if it's the same activity, you go to contextualize one, which is to check if the object of the context in the shared activity is related. So again, remember that I said object is the focus of the moment. So you're trying to check, okay, are they both, you know, more or less sharing the same focus? But you know here that they're not in this example. But if they do, if it is object related, then you go further down, which is function reflect one, and this is to check if the activity for that task is complete. So why do you have to check? Because again, you need to know, okay, in which state are they in semi-active? Are they in passive state? So because again, you need to shrink the search space of the speech acts. So when you evaluate, you have to compare then whether the task is not complete or yet. And then you can sort of like get the value of the activity states, whether, you know, passive, semi-active, or active. And then you return this value of the activity states to the markup ACL. So actually, this markup ACL is where the FIPA ACL guidelines and specification come in. So again, it's like trying to fit into a model. And what it does, the function markup ACL, is just that you convert the analyzed trait into agent messages, and then you output them.
Okay, so you want to end up with an agent, a formalized
yes, the
language.
formless, yes.
And the tree above is all the pain you go through in order to get the real people's real communication segmented and classified and into those.
Yes.
Okay, good. Thank you.
Okay. Sorry. And there is another thing. I have to mention this though. Why did I have to go through all the pain to use this states concept, right? So the other reason is because the FIPA ACL has it lacks in the history. It doesn't look into the history of the conversation. It's just, you know, it takes out the context. So then the semantics is saying like, oh, I have my intention at this moment, it's done, you know, but that's not how it is in real life. So that's why I had to manipulate a bit the semantics, but I still use the FIPA ACL to find the approximation. And should I go on with to explain the other side of the workflow, or are you guys okay? Or I can go to the other, because I'm going to go more detail after this. So, all right. So, okay, to show you step by step. So, for example, you have, so now we're at please Mark, could you explain to me how I can chat with somebody already registered in BuddySpace but not yet in Elijah? So, the first thing you do is, okay, check the activity space of the present and the previous. Is it a same activity? Okay, obviously they're not, so you go to contextualize too. And then when you're here, you identify the object of the context and you check is this a new activity, you know? Is this a new object at the moment? And here, actually, this is when you look into the previous chat logs, and it actually, during the time 1420, the collaborative P has already asked if he could tell him how to add, but he didn't get the answer about this, so he asked again. So you know that, okay, this is not a new activity, you know, it has appeared in the history, so you go to reflect for. So when you're at the reflect for, what it does is that you check if the task for that object of context is complete. So here you know that it's not complete because he didn't get an answer. And, oh, sorry.
In this example, what is the object of context?
So the object of context is chat somebody registered in buddy space. So to chat with somebody, how do I chat with somebody? So it's like, you know, the focus at the moment.
That is the object
Yeah,
of context.
the object of the context. So
One thing here is activity theory has hierarchies for objects, right?
Yeah,
so
yeah.
At this level, object is the focus.
yeah.
As you mentioned, so what is the object at the high level for this activity?
So this is, okay, so this is another thing. When I'm referring to the activity theory, I'm mostly referring to Leontief activity theory rather than the more, yeah. And the Leontief activity theory is more focused on object-subject concept, which is saying like, if you have a tool and what is your motivation, and the subject is you. So let's say you have a pen and I'm the subject, and how does the motivation and your interaction with what you want to do is going in a cyclic approach, a transformation. So there is also another thing which I didn't discuss, like, for example, the object and subject. I mentioned that I use that, right? So actually the object and subject, I use that to parse every utterances, actually. Because I noticed another thing. When you're chatting in one thread, maybe I can, okay, like say this thread, in one utterances, sometimes you can say something on the same line, right? Like you say, oh, how can I chat with someone? Hey, by the way, you don't bother to go to the next line. So
for this particular example, the object is the focus.
The focus at the moment. So it's like
focus at the moment. So that's something you work on, which means, right?
Yeah.
Object is something you work on.
Yeah, you work on, like.
So the focus is. So it's something you work on, is that?
Yeah, it's like, yes, you can think of it like that, like, you know, okay, something I want to achieve, my motivation to talking to you is that, could you please tell me how to add this new person to the buddy space? So it's like,
Is that, I mean,
do I?
So it seems like it should be the, so it should be the skill or the knowledge to add that person to the buddy space instead of the focus.
So pardon again, it should be like a knowledge, yeah.
So how to add the person to the buddy space?
Yeah. That's so it's so. You're saying like it's like intention, right? Like the object of the moment is a little bit like intention.
Right,
Yeah.
Right.
Yes.
That's what
Okay. Yeah, that's true. You can think of it. So then you return the value and the state of the task. So you know here that the state of the task is not completed because, I mean, you know, you don't have, he hasn't replied yet on how to add the buddy space. And then if it's not completed, and then, so if it's not completed, you compare. So the reason this might be like a little bit ambiguous to understand is because sometimes, sometimes they might be talking about the color of the buddy space. So the presence. So they have a lot of problem with the presence problem. Like, you know, I am gray for myself, but I think that gray, that means I'm not online, but I'm actually online. So actually, even the color caused a problem for the collaborators. So you have to compare because sort of like you have to know whether how much is the attention changing? So that's why I say compare activity states of present trait to the one that it was associated to previously. So let's say in this example, at the previous trait that you're analyzing in association, the present trait that you're analyzing in association to the previous trait, you're trying to see what is the changes going on here, what is, and then when I say differentiate, is now that you compare, you say that, oh, okay, he has said it twice. So perhaps I will increase the belief again. That means he wants to get an answer. He's getting the collaborator to get back and focus on him, to give him the attention. And then by differentiating that, you return the activity states. Finally, with that value, you go to the markup ACL function, and then you define the belief, the desire, and the uncertainty. And then when you return that, this is when you have to map the semantics to the FIPA ACL communicative act. And then you restructure them together into the formalized messages. So this is the output. It's in a set of protocols. And another thing, if you realize that, for example, I show like M here, correspond to this message. So this corresponds to this. P 1106, 1108 corresponds to this set of messages. And if you notice that the speech X, they're not just one speech X that I use, because again, this goes back to using the object-subject notation to sort of like parse the utterances. So it's actually trying to see at every moment, even with the dot, while they're chatting, how the attention is changing. Is he still talking about the same thing? So that's why the protocol looks like, a lot. Sometimes it can be a lot more than the actual utterances. That is, again, I said that in the utterances you can talk about many subjects. So what is really nice about this, because having this actually allows me to quickly understand, oh, please inform really, and then you say confirm to the message 26. So you actually can already know if you want to allow later on for the machine learning to induce patterns from these protocols, you already associate the context rather than the chat log. So you know that this message 28 here, so this is like just giving a message number, is saying that he's confirming that he doesn't know about this situation. And another thing which is very useful for me to use this kind of formalized messages is that I can easily sort of like keep track, okay, it's like you're eliminating all the other words, and you see like query if still there, inform if shown green on rooster. So already at the level, it's quite easy for me to understand the flow of the activities. And from these protocols, I managed to sort of like keep track of every changes of the sort of activity that took place during the collaboration. For example, first explain to new user how to use chat system. And when I say action reply with broadcast option to chat, so the user went online and he asked, oh, is this action broadcasting in reply to your chat? Is this a good way to reply? And because of this question, started a new tutorial on how to use buddy space. And the guy said, OK, I'm going to show you how to use one-to-one chat. And it's just showing on a timeline on that date the sort of activity that took place, that sometimes they grow in relationship to previous activities. That's a lot of activity in one talk. Sorry.
Tell me, is this just coincidence that it's all different activities? Because I would have expected that there would also be a return, because an activity was not completed. It started out there, but it doesn't end until 1 week later.
Yes.
So how would that mapping you have up there would not be very suitable for showing that?
No, it wouldn't be for the moment. This is just like on a date basis. But if you want to say, yeah, like if it doesn't end on the same day and if it ends on the second day, like, how do you do that mapping? So.
Yeah, this sort of is implicitly assuming that activities are limited in time.
Yeah, within a day. Is to show.
And not
yeah,
very overlapping, not only sort of, okay.
So,
yeah. Question about 2 slides ago. This code, sorry, forward one, yeah. On the right side, the protocols that you generated there, this is the language, the ACL.
Yeah.
Is this one that you created, or this is the one that came from the
feed up? So only the content level I created, but the speaker, listener, and the speech act, it all comes from FIPA ACL.
Okay, so things like inform, if, confirm.
Yeah, it all come from FIPA ACL.
And then the content layer seems to have a lot of the actual words from the transcript in there.
Yeah, so that's another challenge in the predicate level, because if you have 4-level predicate, that will make it very complex for the machine learning algorithm, for example, to induce the pattern. So this is something that I'm still refining it, because so this is trying to find the perfect balance into trying to capture as much as how people naturally articulate things, so that we can understand at the cognitive level how they do work activity. But at the same time, if you formalize too much, in actual fact, you're removing what is not, because the idea is to understand how people induce communication protocol. So if I formalize too much, then I'm going to lose how people naturally do that. So that content level is another challenge that actually I'm going to talk about the shortcomings.
Okay.
Yeah. So first of all, I talked a lot about, okay, where do we go? What do we look next? But in generally, even if we have that, we don't know the precise variables to look for yet if we want to allow a learning algorithm to recognize the same thing. And so this is also another shortcoming, is that how do you formalize the guidelines from the transition of the activity states, the observations that you have, back to FIPA ACL, communicative act. And then you need to define the rules for all predicate structures. That means, for example, who, what, action, where, who, and there are many possibilities. And what is the best way to represent that? Because, again, if you formalize too much, actually you're just formalizing what people are saying, but in the end you want to learn what they're doing. And so although it seems kind of like time-consuming to do this manual inspection and real observation, but there were many lessons learned. For example, using the cognition theory, even at the abstract level, we don't really know exactly what variables to look for right now, but we already have a new formula just to check and evaluate for communications that's more contextualized. And it works best in a method of in ambiguous situation. And so I manually inspected the data for like 6 months. So that's like one month child log for a day to try and understand the generality that emerges, But also it was very interesting because there's so many things to capture from the chat logs. And although it's time consuming, but it's very worth it, because if I don't spend my months in the chat logs, I wouldn't even come up with at least this framework, and trying to capture the different mode of attention by using activity states. And so another most important thing is that now that we have here sort of like a guideline, and the cognition concepts that we sort of like take for granted, like, okay, identify if activity present trait is the same as previous, but how do you let a program do that? I mean, for us, we have the semantics and we understand, but how do you let an algorithm recognize it just as we do? So then, again, I remind that my original goal was to understand how people induce communication protocols, the patterns. And so the framework was conceived during an exploration. So at that time, the main thing was to get even manual method working at all. So, but now I've been working on the same analysis for about, even until now, I've been working on the analysis for 2 years. So I'm at the stage right now where I'm trying to build a communication analysis model, because now, even if you have the observation, right, and you have the protocols, so even when you look at the protocols, you say, okay, inform if, but it doesn't allow yet the algorithm to tie the activities together, saying that from this time, this is about, from this time to this time, they're in this activity. So the communication analysis that I've been trying to look into right now is more looking into the communication aspect of, what is a context, how do you relate from the content level to the speech act, saying that, okay, the interaction between the speech act and the content level in the previous history, when you compose them, it is about this context, it's about this activity. How do you allow an algorithm to do the same? So I left this analysis after I finished my PhD, and then I tried to look for I'm still analyzing data, because so far that I noticed that if you analyze different kind of work practice, so if you analyze collaborative data, the kind of speech acts you use is greatly differing when you're analyzing animation meeting. So in animation, which was harder for me to capture the semantics, when a bunch of animators are collaborating online, because they use a lot of narration. So, hey, I went here yesterday, so there's more like imagination. Can you imagine this thing going here? A lot of storytelling. So it's even the speech acts that you want to select is different to get the semantics. So now I've seen that I need to reestablish my goal. Actually, the framework that I conceived during exploration is to actually put them into a more concrete method and deal with all the connections that I have to make. For example, as you raised, how do you map the semantics? How do you find them? How do you define that from passive to semi-active state, that this triggers the semi-active state? How do you find that? How do you define from semi-active that this is already in the region of active states? And how do you define the content level? What words to select, and not to select? So finally, again, going back to my first, when I said my goal is, again, to finish where I started, So I'm more or less in trying to make sense of activities, but I need to go there at recognizing events, finally. So, and nearly end to my talk, and I'd like to thank a lot of people who has been very supportive and very patient. My PhD supervisor, Stefano A. Cherry. So he's from the agent people, and Professor Bill Clancy, Professor Mark Eisenstadt, and the Elijah group members and all. And yeah, thank you very much for your attention.
Thank you.